Alright, now let's try solving the left view of the binary tree. So here is our problem. Okay, left view of the binary tree, given a binary tree, return left view of it, left view visible, the task is complete. Okay, let's consider this example itself. Here, if I can copy it, let's see. Okay, I think it's a bit problematic. Yeah, no worries. Yeah, now it looks great. So yeah, the tree looks something like this, and you need to return the left view of it. So you need to return these values, right? 1, 2, 4 and 8. Okay, if you okay, let's try to think it the BFS way, right? You only need the first values, right? So what happens in BFS that you traverse all the levels. So what your BFS would look like, your level order traversal would look like this, will look something like this: 1, 2, 3, 4, 5, 6, 7, and then you will be having 8. But you don't want all the values, you just only want the first values, right? So what you can do is you can store whole level order traversal by using BFS, and you can store only first values. That is, for every vector you can store the v0, right, the 0th value. So let's say you have your level order traversal in LVL, right, which is a vector of vectors. And what I'm saying is, for every vector that exists in this level, right, so V represents the elements of a level. You just store answer dot push only the very first element, that is v0. So that's how you will be able to get your answer using BFS. But here you can see that you are first of all storing all the values, then you are creating another vector answer to store your answer, right? Also, you need to store the whole level order traversal first, where you will be storing these extra values that you don't want, right? So what you can do is you can take this tree and let's say, can I take this whole tree below with me? Yep. Let's try to take this tree here, right, and let's move here. Okay, erase these. Okay, now what I'm saying is, do a level order traversal, and how can you make sure that you don't store these values like these, like this? You only end up storing these values, right? I mean, there are multiple ways you can do this. While doing a level order traversal, you can, okay, I'll tell you the simplest solution. You can, instead of processing the left child first, you can process the right child first. You can push right child first, and then you can push left child first in the queue while doing level order traversal. So what will this do? If you do something like this, you will end up processing the right child first, and then you will process the left child first for the very so what will happen, that let's suppose in the case 2, 3, for 2 you will store your right child first, so it will store 5, and then you store 4, in the queue, right? And then you come to 3, then you store your right child first, then you store your sixth. Wait, you will I messed up something. So like I said, you should process your left child later. So you will process your right child first, that is 3. So when you will push for 3, you will push 7 first, then 6, and then you will come to 2. Then you then you will push its children in the queue. So you'll end up pushing 5 first, and then you will push 4. And now after this level is done processing, 2 and 3 has been processed, so this level is over, and then the queue will process this level, right? As you can notice that the queue will process this first, then this, then this, then this. So what I do need is, I just need a temporary variable, right? Let's call it x, and I can give any initial value to it, and just traverse these nodes and update the value with x. So as you process this node first, just update its value in here. As you process this, just update its value, then update this value, and then update this value. At the very end, at the end of this level, you will end up having 4 in your x, and that's what you want for any level, right? The very first value, and just store it in your answer vector. You can do this thing for every level. What we need to do is, we need to store our right child first, and then we need to store our left child. That this will result in processing the right child first and left child later. So the left child will replace those values that were stored by the right childs. So again, we can do a level of the traversal. So let's write a case. If not root, then we need to return an empty vector. And as for the we can do BFS using queue, right? And then we can push root into it, and we can do it. Our queue is not empty, right? And for every level, let's take our temporary variable, which is x, to be -1, and let's take out the size of queue. This is our size of the level, and we will try to process this level. While processing this level, we will take the value of current node and update it with x. So my x becomes, first of all, take out the node which is present in the queue, that is node star. Let's call it node, or let's call it node, and then we can do q dot front, and then we will pop it from the queue, and then I'll update nodes value, x values with nodes value. So x is now storing the value of node, and now here we store the right child first. So if my right of node exists, then I'll store that in the queue. And then only I will store my left, if that exists. So if node left, then I can push that into the queue. So when my processing is done for this level, right? Processing the level, current level is processed now after the end of this loop, then I should store this in my answer vector, and then I should return answer. Also, I need to make the answer vector first. So here I'll make my answer vector int answer And here in the case of GFG they use data, right? We can see in the struct. Let's run this and see if there is any problem. So it says compilation error. Okay, that is answer dot pushback, not push. Okay, it is giving me correct output. Let's try to submit it and see. Okay, all the test cases has passed successfully. So yeah, that was it for the left view. But before ending the video, let's try to see the time complexity. As for the time complexity, it will be O of n, because we are traversing every node first. And as for the space complexity, we are only using the space for returning the answer, right? And also we are using a queue which will be having the space according to the width of the tree. Whatever the maximum childs are present in a level, that would be the space complexity, plus the space complexity for returning our answer, which will be equal to the number of levels, number of different levels present in our tree, which will be equal to height. So the space complexity becomes O of h, that means O of height plus O of big O of width of tree, and the space complexity becomes O of n, right? And that was it for the time complexity and space complexity. Now let's talk about how you can do it using DFS as well. For DFS, what you can do is let's think. Okay, let's say any tree is there, right? For DFS, what you can do, you can take a map and you can process the left child first and right child later. And if the key is not present in map, then only you can store the value for that level in your map, right? MP level equals to whatever the roots value is, roots data. But while doing DFS, first of all you go to the root, you check if that thing exists in map or not. If it doesn't, then only you can store, and otherwise you move to the left child, and then you check again the same condition, then you move to the left child, and then you come back, and then you want to go to the right child, right? So yeah, in this similarly you can do DFS. So yeah, thank you for watching.